Hello, hello. Welcome to our webinar, Beyond the Road, a demonstration and discussion. My name is Crystal Beauclair, and I am Forth's Marketing Associate. You won't hear too much from me. I just wanted to welcome you all and remind you all that when you have questions, to please submit them in the attendee chat. We're very excited to have you here today and to present this topic. So without further ado, I'm going to introduce our wonderful moderator, Thor Hinckley. Thor, please turn on your webcam.
Thanks, Crystal. Welcome, everybody. This is Forth's Beyond the Road, a demonstration and discussion webinar talking about off-road electric vehicles. And we're so excited to be with you. And we have quite a few wonderful projects to talk about, and we have some great speakers to demonstrate. So before we get into that, I would like to have you hear a bit from our sponsor, Treasure Cities Clean Cities Coalition, who working with Idaho Power have been kind enough to sponsor this webinar. So Beth Baird is with the the Treasure Valley Clean Cities Coalition. And Beth, do you have a few things to say?
There we go. There. Hi. Thanks, Thor. Hi, everyone, and welcome. My name is Beth Baird, and I am with the Treasure Valley Clean Cities Coalition. And along with Idaho Power, we're happy to be sponsoring this webinar and have worked with Forth to put this together for you. And I'm so glad you can join us today. As you know, this year has been a really bad year for in-person events, and it has not been a very good option for those sorts of things. And many webinars have been offered in their place. We've tried to make this webinar a little bit different than most and focus on practical information from local users of small electric vehicles and forklifts. These are EV options that are not necessarily generally utilized, but could be very useful to your businesses. Additionally, with electric trucks coming on soon, we've got information for you on the current expectations related to their introduction. Again, thank you so much for joining us, and I hope you'll find this webinar informative and that your time will be well spent. Back to you, Thor. Thanks.
Thank you, Beth. So I'd like to spend a little bit of time just introducing the speakers on today's webinar. We've got quite a variety of really talented people talking about their experience with off-road electric vehicles. The first is Dale Gibson. Dale's worked at Idaho Power for about almost 14 years, and 11 of those have been as working in the investment recovery department. He's a leader in that group. He's responsible for recycling materials, the selling of used assets, has waste disposal, and working with groups on donations. He's a certified forklift driver for counterbalance and narrow aisle forklifts, and is really a resident expert on electric vehicles, primarily in the forklift arena. Next will be Wade Hubsmith, a sustainability initiatives coordinator for Boise State University. Wade eagerly embraces the opportunity to create a long-term model for vehicle sustainability at BSU. Wade is a master automotive service technician with over 30 years of experience. Wade has been an assistant professor at Boise State and at the College of Western Idaho, teaching automotive technology. He's also experienced in teaching a number of other training courses, including technical certificates at BSU. He's an assistant professor at Boise State with, as I mentioned, 30 years of automotive experience in the technician arena. Idaho has Idaho teaching credentials, and ASE is a certified master technician. Our third speaker is Chelsea Sexton. Chelsea has been working to accelerate electric transportation since the 1990s, starting with way back when in the 90s with the General Motors EV1 program. Her diverse adventures have since included co-founding Plug-in America, as well as guiding Vantage Point Capital Partners' early investments in Tesla Motors, and directing the Automotive X Prize to encourage the development of compelling, highly efficient vehicles. She continues to work as an advisor, speaker, and a friendly co-conspirator with a number of companies, NGOs, and policymakers around the world to make the movement of people and goods cleaner, safer, and more accessible. She is the US president for the Fully Charged Show, likes torque and horsepower, which are more than anyone rightfully should, and tilts at windmills as a lifestyle choice. That's Chelsea Sexton. So without further ado, I would like to launch into our webinar, and we'll be saving questions till the end, but I'll take it from there.
Hi, this is Dale Gibson here with IDAHO Power. I'm the investment recovery leader, and I've been doing this position now for pretty much almost 11 years. During that time, I've had many different pieces of equipment come through here. And one of the latest ones we did, starting back in 2017, was our electric forklift. Idaho Power itself, we cover 2,400 square miles in Southwest Idaho and Eastern Oregon, with 17 low-cost clean hydro projects, as the core of our energy source. Idaho Power, we also have more than 570,000 customers. We pay some of the nation's lowest energy prices and enjoy some of the cleanest energies. Idaho Power, our goals for 2030, the passenger cars, we're looking at going 75% electric, and 100% of those new purchases after that will be full electric. Other vehicles, including the SUVs, we're shooting for 35%. And for forklifts, we want 75% of those to be electric, along with 100% of those new purchases. Some of the ones that we are actually very interested in seeing coming up are going to be some of the telehandlers. Those are more of your off-road, out in the middle of nowhere type forklifts to see what we can do, what the industry can create for us in those type of environments. Because for us, that's one of the challenges of trying to go electric is finding those type of vehicles that can service us while we're out there. I have a short electric video or electric forklift video to present here. Whenever we first got the forklift, we're all getting kind of used to them and everything else. And so we went ahead and shot this video for you guys to enjoy, and we'll go ahead and we'll start it.
Bernardo, sustainability strategist. This is one of 4 new electric vehicle forklifts that we purchased in 2017.
I'm Dale Gibson. I'm the investment recovery leader down here. Forklifts are used daily down here. They are our main tool, especially inside the warehouse, getting material out to our hazmat building and stuff like that. It is going to be our electric forklift that we now use.
It's very effective. It's quiet. And because there's no burning of fuel, there's no emissions, so it's actually healthier for indoor and outdoor use.
My name is Joey Fielder. I work here at Transtest as a material handler 1. On average, since we've had it, we've been getting on a full charge about 3 solid days of use out of it.
With this, whenever you get down to the 20% range, it actually gives you an audible alarm. So it lets you know, hey, we're getting low. And plenty of power to still finish up what you're doing and get back here over on the charger.
Shit, we bought 4 because we really believe in them, and it's all part of the company's effort to electrify mobility.
It's a win-win.
One thing is once we shot that video, that was pretty early on with having the forklifts. And since then, one of the biggest things that, we get asked is, how's the charge time still doing? It is still, off that 1 hour or off that, overnight charge, we're still seeing that 3 day drive time. Of course, we're not on the forklift a solid 8 hours of the day, but it is being used quite often, especially inside. Again, one of our favorite features about that is not having that exhaust smell inside the warehouse anymore. So we really like that. As far as Idaho Power, our current electric forklifts, we have 2 narrow aisle forklifts, and those are the ones that inside a warehouse where you have tight pallet racking, stuff like that. They'll scoot right in between there. You're able to go up, turn to the side, and actually shoot out and pick up your pallet, then pull it back and then drop down. But the majority of what we have are counterbalance forklifts. We have 2 5,000-pound ones, 7,000 pound ones, which that's what my forklift is here in the investment recovery warehouse. We have 1 9,000-pound one, and we have 1 big 12,000-pound one. It's been a great addition again, to our team to have this, and it's been so helpful. Some of the benefits, again, with an electric forklift, a lot of times with your diesel or your propane, something like that, when you go to lift something, to get it to actually lift with a little bit more power, a little bit, quicker speed, you're usually, pushing down on the static brake and then giving it gas, which is, again, pushing more exhaust out into the warehouse. With the electric forklift, you pull up, you pull back on the lever, it's lifting the pallet. The other nice thing is the footprint that this electric forklift takes is the exact same as our old propane one, and I still have an additional 2,000 pounds of lifting capacity compared to the other one in the same footprint. Being quiet, again, is great for being inside the warehouse. Don't have to wear as many earplugs, stuff like that, to help with hearing and stuff like that. Another nice thing is whenever you're out and about in the yard picking up something, you don't always check that propane tank before heading on out there. So there's been numerous times when you're out there with a propane forklift. Next thing you know, it sputters on you and dies, and you're making the long walk with the propane tank to go switch it out with a full one. With the electric one, we do have that at 20%, and an audible alarm does come on. Allows us to finish what we're doing, and it's loud enough in there where you can't ignore it. You definitely do bring it in and throw it on the charger. Usually we don't have to do that too often during the week, but come about midweek, near the end of the day on Wednesday, that's typically when we'll hit that. Since we got the electric forklift, there's been a lot of great things about it, but we did run through some challenges. The one thing we learned, these electric forklifts are also new to our vendors. So we got to make sure whenever they send out the charger with the forklift, it is the right charger and it's set to the right settings. Amperage is huge for whenever charging batteries, and if that amperage is too high, next thing you know, you can cook a battery and put a hole in one, which we did. So we've worked with our vendor, and they're actually really good about getting the battery fixed, getting things done right. Another thing we found that's great is there's an autofill feature on ours. We're able just to plug in this battery powered water filler, plug it in, we hit the button, and you go until it stops. One thing we found though is it starts kind of at one end of the battery and goes all the way over to the other end as it's topping off cells. We found that if we go ahead and split that in the center, where then it divides out to the sides, it actually works a lot better. It seems like we don't overfill some of the other batteries up in front while we're trying to stuff water through there. It's some of those things that you learn, whenever you're getting into it. and you just have to kind of change some behaviors on that. Another thing that we really do like about the brand that we have is we still have a lot of different options we can put on there for lifting. It hasn't, you know, it hasn't made it like limited where we can only do a certain amount of things or anything like that. It's given us still the full capacity that our old forklift did, along with better lifting capacity. We can still put on different attachments on the front. We still have all the same, tilt and auto squeeze and spread apart for our forks or fork positioners. And the other nice thing is it's quiet. We really enjoyed that, and then no exhaust. And apparently this actually went a lot quicker than I thought it was going to, so I am now on to the next presenter.
Thank you, Dale. That was a great presentation. The next topic we wanted to discuss is neighborhood electric vehicles. So there's obviously a number of different brands of these neighborhood electric vehicles. Typically, their top speed is about 25 miles an hour. The range is in the neighborhood of 30 miles for the total range on a full charge. And they can transport a maximum of about 3,000 pounds. 3,000 pounds, and these are vehicles that can charge from a standard 110 wall outlet. So they're very versatile, they're very flexible, and they're very user friendly. So without further ado, let's have Wade tell you more about neighborhood electric vehicles.
Good afternoon. I'm Wade Hubsmith with Boise State Fleet Management Services. We'd like to thank you for asking us to share our sustainability initiatives with you this afternoon. Boise State strives to be a leader in sustainable transportation solutions. We know the consumption of fossil fuels and vehicles produce greenhouse gases. The majority of the greenhouse gas emissions are carbon dioxide. Transportation accounts for about 28% of greenhouse gas emissions in the United States. Greenhouse gases trap heat and contribute to climate change, often referred to as the greenhouse effect. We know that by reducing our carbon footprint, we can help reduce climate change and improve our local air quality. We are so fortunate to live in Idaho. Idaho is rich with many renewable energy resources. Nearly half of Idaho Power's energy comes from their 17 hydroelectric power plants on the Snake River. Hydropower is clean and inexpensive to produce. Idaho Power is also helping expand wind, solar, and geothermal power throughout Idaho and Eastern Oregon. Little history on what Boise State's done so far. Boise State has been implementing sustainable transportation options for about 20 years. From 2001 to 2020, we've purchased E85 compatible vehicles when available, and that counted for about 40 vehicles. In 2001, we purchased 2 electric Taylor-Dunn service trucks and a hybrid Toyota Prius. In 2009, we purchased our first Polaris Gym, and these are electric service carts that we use here on campus. In 2012, we purchased 2 additional Polaris Gyms. 2013, we purchased an E-Ride all-electric service truck. And in 2014, we purchased 3 more E-Ride service trucks. In 2014, we purchased a hybrid Ford Fusion. In 2017, we purchased a Nissan Leaf. All these vehicles were purchased in place of conventional powered vehicles. We wanted to talk a little bit about the E-Ride with you today. We have about 7 to 8 years experience with the E-Ride. The average cost of an E-Ride is $25,000. They can range anywhere from $22,000 to $35,000 depending upon the options. These vehicles are classified as a neighborhood electric vehicle. They can be licensed for use on public roadways up to 35 miles an hour. E-Ride offers two models. They have a 2-door and a 4-door model, and they have a wide array of options. These vehicles can be equipped for utility, passenger, security, postal, fleet, maintenance use. The E-Ride is known for customizing their products to fit their customers' needs. There's several battery options available on the E-Ride. The standard batteries are flooded lead acid batteries. You can get a 100 amp hour lithium ion battery. It's a $4,000 option. These are the batteries that we have in our E-Rides here. Our E-Rides here are used by our maintenance staff. They come in the morning. The vehicle's plugged in when they get here. They take the vehicle and use it for their 8-hour shift. And then they bring it back, they plug it in, and after their 8-hour shift, the custodians come in. They take the vehicles out and use them for their 8-hour shift. And we haven't had any problems with batteries dying during these shifts as long as they're kept plugged in after they park. They also have a 200 amp hour lithium ion battery available. Crystal, my slides are too far on the bottom. Is there any way I can get the slides to move up?
Apologies, Wade. It seems like when they uploaded to any meeting, they distorted a bit. There's not a way that I can minimize the slides. I apologize so much. If you want to take a minute and pull them up on your screen and continue talking, I'm sure the audience totally understand.
So I can just use my PowerPoint on my screen if that's okay. There we go. Is that okay, Crystal?
Yes, absolutely. If you're just looking to continue reading, you can do that, or there's a share your screen option at the beginning. Apologies, attendees, technical difficulties.
Hey, can Corey or Whitney change the slides for the audience, and I'll use my slides that I have?
Well, if it's coming from your screen, no. If you want to just continue reading off of your screen, though, the audience won't be able to see what's written on, but you can just go ahead and keep going.
Okay. So a little bit about the lithium ion batteries. We really prefer the lithium ion batteries. The lithium ion batteries are essentially maintenance free, which is a really big deal for us. With the lead acid batteries, you have to add water to the batteries. You have to clean the terminals, and there's a lot of corrosion associated with the lead acid batteries. So we really prefer the lithium ion batteries. The lithium ion batteries can last up to 4 times longer than the flooded lead acid batteries. And they also provide a consistent performance throughout their full state of charge. I'd like to talk a little bit about E-Ride range and charging. So if you get the E-Ride with the flooded lead acid batteries with a 1.5 kilowatt charger, the average range is 80 minutes or about 30 miles of operation. They have a built-in charger, and charge time on these is 7 to 8 hours. It's a 110 charger. Battery life expectancy is 2 to 5 years. If you opt for the 100 amp hour lithium ion battery with a 6.6 kilowatt charger, the average range on those is 80 minutes or 30 miles of operation. They have a built-in charger. The charge time on these is 1.25 hours. It's a level 2 charger, and it's equipped with a J1772 connector. Battery life on these is between 5 to 20 years or 2,000 cycles. If you get the 200 amp hour lithium ion batteries with a 6.6 kilowatt charger, the average range on those is 140 minutes or 55 miles of operation. They have a built-in charger. Charge time is 2.5 hours, and they're also equipped with a J1772 connector. Wanted to talk a little bit about battery life. There's 3 factors that determine battery life: time, cycles, and maintenance. We were curious as to what a cycle meant, so we contacted E-Ride And E-Ride told us that a cycle means you've depleted 80% of the battery, you've plugged it in and recharged it. They also stated that say you deplete 30% of the battery and recharge it, that is not a cycle, that's a partial cycle. So that we thought that was pretty interesting. And of course, maintenance is huge on battery life, especially with the lead acid batteries. You know, like the lithium ion batteries, there's little to no maintenance. With the lead acid batteries, maintenance is critical for the life of the battery. I want to talk a little bit about E-Ride service and repair. So these vehicles are equipped with a diagnostic connector. You can download the software from E-Ride, and then there's an interface so that you can hook your computer to the E-Ride. And what this does, it allows technicians a broad range of diagnostic capabilities. For example, technicians can pull diagnostic trouble codes. They can look at data to assist them during diagnosis, and they can also reprogram controllers. Another feature that they have is there's a main battery disconnect, and this provides safety so the technician can disconnect the battery so that it's safe to work on the vehicle. E-Ride also has some online offerings. They have a online parts manual, owner's manual, service manual, wiring diagrams, and service flow charts. When you order parts from E-Ride, standard delivery is 3 to 5 days. But if you have a vehicle down that's not running, they will overnight the parts to you, whether it's warranty or customer pay. You know, the big thing about E-Ride is their technical support. They offer immediate access to the factory for technical support for service, diagnosis, and repair. And what that means is if you're working on an E-Ride, you can call the factory and they'll put you right through to the engineer that designed and built this vehicle, and he will help you step through the diagnosis and repair of the vehicle. I don't think we have ever called E-Ride where they weren't able to assist us and walk us through the steps and repair the vehicle. You know, simply put, E-Ride has the most incredible customer service we've ever experienced. A little bit about our experience with the E-Ride. The vehicles have worked very well on their assigned role here at Boise State. It's critical that you have a designated parking spot with infrastructure for success. We have realized measurable savings in carbon reduction, fuel, and maintenance costs with the E-Rides. One of the things we wanted to do is we wanted to compare one of our conventional powered service vehicles with an E-Ride. So what we did was we looked at a conventional powered service truck and we calculated the carbon output of that vehicle for year, and it put out 1.07 metric tons of carbon per year. So we looked at a 5-year picture. After 5 years, that vehicle put out 5.35 metric tons of carbon. Our E-Ride put out 0. The next thing we wanted to compare was fuel versus charging costs. So our E-Ride is $66 a year to charge, and our conventional powered pickup is $738 a year to put fuel in. So if you add that up over a 5-year period, it's $330 to charge our E-Ride and $3,690 for fuel in our conventional powered vehicle. The other thing we wanted to look at was we wanted to look at maintenance and fuel cost. So we compared our E-Ride against one of our conventional powered service trucks. In this case, it was a 2012 GMC Canyon. Year to year, that cost varied, but if you look at the line graph, the E-Ride was much less expensive for maintenance and fuel costs. We got all this data off our WEX fuel management system and our fleet management systems. So this is hard data that we had stored. So far, we currently have 16 sustainable energy powered vehicles in our fleet. 4 of them are E-Rides, which is the all-electric service truck. These vehicles have 0 tailpipe emissions, and they're used in place of conventional powered service trucks. We compared 4 conventional powered service trucks using a similar capacity as our E-Rides. Our data showed that these 4 conventional powered vehicles produce 9.16 metric tons of carbon emissions per year. And again, we source that data through our WEX fuel management system and our fleet management systems. By incorporating hybrids and electric vehicles into our fleet, we have substantially reduced our carbon emissions footprint. Calculated total carbon emission reduction is 32 metric tons per year. Our long-term goals here at Boise State is to be 30% of our fleet, or about 42 vehicles, powered by sustainable clean energy by the year 2030. We believe we can exceed these goals with the availability of more vehicle options being offered by the manufacturers. We've identified 84 vehicles in our fleet where an electric or a hybrid vehicle would be a good option. We have set realistic goals by identifying these vehicles in our fleet where a hybrid or an electric vehicle would be a viable option. A couple of the metrics that we looked at were vehicles traveling less than 2,000 miles a year, and their primary use was here on campus. We know to achieve these goals, we're going to have to continue to build and strengthen our partnerships. We're going to have to continue moving to a centrally managed fleet model, and we're going to have to secure funding sources for infrastructure and vehicles, along with technical training for our technicians. We'd like to thank everyone for attending today. During the question and answer session, our team would be glad to try and answer any questions you may have. Thank you.
Thank you, Wade. No, that was a really great session. Thank you. And we're about to move into the electric delivery van and the future of, electric vehicles moving into heavier duty than just light passenger vehicles. So some of the brands here at play are Ford, a name you've all known, Rivian, brand new company, should be producing cars, hopefully electric pickup trucks later this year. Changi, Changi Workhorse, Changi, which is a Chinese company, Workhorse, and the Changi Workhorse has 266 horsepower and 198 kilowatts of power, and an amazing 317 pounds of torque, carrying capacity of 3,800 to 4,200 pounds, and a range of over 150 miles. So as we see more and more delivery vehicles on the streets in response to online shopping behaviors by the public, these vehicles are going to point us towards a cleaner future. So with that in mind, I'd like to ask Chelsea to move into the picture and take it away.
Perfect. Thank you. Thanks for letting me crash your party. I am Chelsea. That is actually one of those Rivian trucks that Thor just mentioned. And I often find myself, when posed with questions about cargo space, trying to demonstrate it very, very personally. So that's a cargo tunnel that runs through the middle of the bed, so you can put snowboards and skis and various things in it. But it also houses one person quite comfortably. As mentioned, I started my career about 25 years ago on a little car called the General Motors EV1. I fell in love with electric technology and have worn many hats since, but always in this space. For the last 15 years or more, I have been independent, so I get to play with everybody, and I get to be very agnostic as to business cases and things like that. And I work almost entirely on the deployment side. So putting vehicles on the road or into programs, putting charging in the ground, helping policy and incentives and things like that get set up. I play less on the R&D side, so very practical matters. And so over those 25 years, much of this has kind of seemed like a turtle race at points, especially in the spaces that we're talking about, because so much of the effort has been focused on private passenger vehicles. But it is starting to change. And so, as mentioned, I'll do more of a landscape thing, not nearly as detailed, at least until the discussion portion, about sort of urban goods movement, non-road, landscapey stuff at a high level, and we'll go from there. In terms of why these things are starting to change, some of it is absolutely component and battery cost. Bloomberg New Energy Finance is a favorite research firm amongst our folks. They're very level-headed in terms of the optimism and pessimism balance, and they peg very much the future of this to the price of lithium-ion batteries, and in particular to batteries getting to about $100 per kilowatt hour, which is roughly what they estimate will be the cost parity between internal combustion and electric vehicles. So once we kind of get to that point, which they expect to be about 2022 or 3, generally speaking, at least regular electric vehicles will be about the same cost to produce as internal combustion or diesel. Whether or not that makes manufacturers more excited about the idea is a different question, but certainly that is a huge piece of the puzzle. And so similarly, as a result, they expect light commercial vehicles, sort of this last mile urban delivery goods movement space, to grow from 2% sales today to about 28% sales globally within the next decade or so. So definitely quite optimistic. Policy is also a huge piece of this. As in all things electric vehicles, it's been driven by policy for decades now. It has been primarily CAFE standards in the US, average fuel economy. In Europe right now, it's CO2 standards, and China is the fastest growing region on electric vehicles with very much government mandate toward that. But within the US, the California Air Resources Board also has a fairly significant piece in this, and they started the passenger vehicle mandate back in 1990, but since have gotten into also advanced clean trucks programs and advanced clean fleets programs, which apply to these other spaces that we're talking about. So anything class 2A and above, about 8,500 pounds or higher is advanced clean trucks. Anything lower than that is advanced clean cars. So between the two, they encompass all of these vehicles except for the non-road. So anything that goes on the road, it counts. Anything else, the forklifts and all that, is a whole different set of standards. And there are about 12 or so states that carbon copy what CARB does. So on one hand, California is not the center of all things, but all of those states put together comprise enough of the buying market that they actually have an effect on what gets produced. So even though Idaho is not a CARB state, all the other states benefit from companies offering things they wouldn't have offered necessarily if not for some of these programs. And then lastly, there is some movement, less in the US, but probably coming on more municipal and regional policy, things like congestion charges, the various conversations around, banning internal combustion vehicles in city centers, stuff like that can also play a role in getting manufacturers to switch what they're making. And then finally, also brand interest. So companies like Coke and Cox and Pepsi, Frito-Lay, FedEx, UPS, there's a bunch of the Anheuser-Busch now, started years ago in really wanting to transition toward electrified vehicles long before they really existed, in part because they started to see the writing on the wall for total cost of ownership and the fact that they would be cheaper to operate over time, but also because they started to develop their own internal sustainability goals, and especially those companies that do business globally have started to resonate to climate change expectations and expectations from their customers that they would become more sustainable and more progressive, somewhat in a PR optics sense, but also backing that up with real moves. So lack of product has been our number one hurdle pretty much in all EV spaces for a while, to the point that especially when those companies started some years ago wanting to go electric, they basically had to hunt down tiny little startups to make them one by one. Or in this case, the Deutsche Post, DHL, started to make their own. They finally just said, forget it. We can't find anyone to do this for us. We're going to start doing it. And after the first couple of years, Ford kind of came in, they partnered on it. But this street scooter, that they call it, started just from lack of being able to find it anywhere else and taking that initiative. FedEx, similarly, outside of the US, Nissan actually made this delivery van. It's an NV, which exists here, NV200. Electric version existed in Japan and Europe. It was made in Barcelona, but it was never made available in the US. There was a fair amount of appetite for it because it's a nice size. It's not too big, it's not too small, but the range on this one was really short. It was a Leaf in a van body. So I know Idaho Power would know exactly how that would translate on range in a bigger car. This was on 70 miles on a good day. Rivian, as mentioned, is sort of the darling of the startup space at the moment, at least for the last couple of years. Amazon was not the first company in to support electric vehicles for goods movement, but certainly they got a ton of attention when they tossed $500 million or so into Rivian. So Rivian will be delivering 100,000 of these these delivery vans in the next few years. They're making 3 different sizes, so something kind of for everybody in different regions. But that certainly has helped open a lot of eyes toward this space. And in fairness, the last year or so, COVID has helped and hurt, helped in awareness, certainly from the standpoint that more people are at home having things delivered to them. More conversations are starting to happen about how those things get delivered. And at the same time, an increasing awareness in pollution effects on frontline communities. The USC Keck School of Medicine did a study for 13 years and determined that children that grow up within 1 mile of a freeway have permanently diminished lung capacity. So things like that have actually been where the EV conversation started from a pollution and health standpoint long before climate was ever part of the conversation. Ford has been the most recent announcement. The Transit, which has been on again, off again now for quite some time. They released a concept about 10 years ago now, but just in November, they announced that it's finally going to come to market as a 2022 model. It's going to start at $45,000, be available outside of fleet scenarios, so you can be a fleet of 1 if you want to. The range is going to be about 126 miles, which I know will still sound really low to a lot of people. Ford's position is that they have 30 million miles worth of data from non-electrified transit customers, that they know exactly what people do with these cars, exactly, or these vans, exactly what businesses do, and that they've determined the average use is 76 miles a day. So 126 gives you a nice cushion for something else, or if range reduces a little bit in the winter, things like that. So Change is actually an American company. It's based in California. It's not Chinese, but they decided to get a little clever on the name. It was founded out of what used to be Smith Electric, if anyone's nerdy enough to have known of that startup back in the mid-2000s or so. They just partnered with Ryder, in part because all these startups have distribution issues, quite frankly. I mean, the lack of capacity, they can't be all things to all people. And so they're starting to partner with some of the fleet management companies themselves to basically reach other businesses as a B2B model. So Ryder is going to help out Change. And Workhorse, for that matter, was a different announcement. Arrival is also a new sort of darling startup in this space. They're British-based, actually, but they just established U.S. headquarters, announced yesterday in Charlotte, North Carolina, and they're going to do a manufacturing facility in South Carolina. So they also are doing the delivery van space. They have investment from UPS, obviously, and Hyundai Kia. So they're another one, kind of like Rivian, that's starting to get some attention through their backers. And then this is not technically, it's last mile, but it's bigger than we think of. This is a drayage truck. And certainly when we think about shorter haul, even though it's more cargo at a time, these sorts of opportunities are also a factor and an interesting use case. So in this case, this particular one goes from the port of Los Angeles to downtown LA. It's about 20-25 miles. So it doesn't do a huge number of miles. It just goes back and forth between those two places with a cargo container from the port of Long Beach. So it's not for everybody, but it's still in this category of relatively urban use, last mile, so to speak. On the flip side, a Norwegian company makes a little vehicle called the Paxter, and the New Zealand Post uses these in part for their flexibility to be able to drive on sidewalks or up long driveways, things like that. Particularly useful for packages, so and a bit more weather resistant than a bike or something like that. But we're seeing more of that kind of right tool for the job thinking, and particular in India as well as one of the newer emerging markets, electric tuk-tuks. So there are a variety of companies that are using these for e-commerce and urban delivery, even not even bothering with a van, just basically a smaller vehicle for very local use. And same thing in Europe. In part because the streets are narrower and vans aren't as useful there anyway. So a split between sort of the tuk-tuk style and cargo bikes, actually. As mentioned, the neighborhood electric vehicles are finding they're still being enjoyed on campuses and things, but they're also enjoying an interesting new life in the context of autonomous vehicles. So this particular one is at the University of Michigan, but there are other ones elsewhere. These happen to be Navia's. It's a French company that makes these neighborhood electrics, but the Polaris gems are being used by May Mobility in Detroit and a few other cities and various places. So, and we have now food delivery robots. some of these will find their use cases better than others, but it's interesting also to watch sometimes the machine get very, very small and very last mile, last block, but it's certainly being played with in a few different cases, and also a riff on autonomous. It's not exactly, but it's in that spirit. And then a few other, some non-road, some road, but urban, different things. Airport electrification, big and small airports, is starting to get very, very popular. In part, forklifts, as mentioned, but also APUs, luggage trucks, tugs, things like that. The more that we can electrify outside of the planes, the more useful and cheaper to run. The planes themselves remain the hardest nut to crack, but there's work going on there as well. Street sweepers are becoming a thing, as are trash trucks. This one happens to be a Volvo. Their Mac division is going to actually start selling these next year, so this is an earlier concept, but there are several providers on many of these things now. And then lastly, a couple days ago, the first electric and autonomous tractor was unveiled by a little company called Monarch. So there's all sorts of different use cases that are starting to go electric and be experimented with. And then last but not least, I want to give a bit of a shout out to the notion of a plug-in hybrid platform. This is still, it's kind of gone by the wayside a little bit on passenger cars, although people still love their Volts very much and it's an awesome car. But certainly in the more medium and heavy duty space, that category is still interesting, in particular to utilities and municipalities. This particular one is not at all a delivery truck, of course, but it is Pacific Gas and Electric. It was made by Cummins, who helps convert some of these things. And they hold particular appeal because of the fuel diversity. It aids emergency response and resilience. It's great in rural areas. That's lower infrastructure requirements, lower chargers work just fine. You're not trying to deploy the fastest DC, most expensive charging to try to charge up a big truck or anything like that. So the versatility there still makes that category interesting, even though it wasn't exactly our focus today, but I'll just add it in there as a side point. So that's kind of what's going on right now. Thank you very much.
Thank you, Chelsea. That was a great presentation. Sorry for that misattribution of change. Yeah.
It's their fault. They tried to get clever.
Yeah, well, thank you again for being your thoughtful presentation. So I wanted to open it up for questions from the audience, and we've got a little bit extra time, so we're ready to take questions. So please, I'd ask you to put those in the attendee chat, and so we can jump into those right away. So the first question, I believe, is for Fourth, and it's about, and I'm open obviously to any of the participants that might also have answers for this, but have you done any programs in the Midwest, or would you be interested in doing so? And the answer to that is yes. We've done a number of projects in the context of the Bloomberg American Climate Cities Challenge. We're working in Indianapolis. We're working in, gosh, help me out here, Crystal. I believe Chicago, and a couple of other Midwestern cities on transportation electrification for the municipal governments. And this is for their climate reduction goals. So if any of you guys have any projects going on in Chicago or the Midwest, let me know. This next one might be more appropriate for our panelists. Do you have any guidance or recommendations related to the pursuit of careers to support the deployment of more electric vehicle systems?
I know here at Idaho Power, we do have a group, Patty Best. She's one of the ones in our group that goes around and helps, promote the use of electric vehicles or even a combined type cycle. We do have a few line beds that are a what they call hybrid line bed that uses both diesel and then battery powered. We've done some things with our Ford F-150s, adding in battery packs, things like that. She's a big push here. I don't know if they're adding onto her team, but you can always go to the Idaho Power website. We always have our open positions on there.
Wade, your thoughts, or Chelsea?
Yeah, I mean, I think it depends a little bit on what you mean by EV systems. But I mean, so on the vehicular side, there are a bunch of many of the trade schools and folks that already do sort of automotive technology programs have added in hybrid and EV programs. So, and there's also more private training institutions, the National Alternative Fuels Tech Center, folks like that. And from a more general interest, if you're not quite sure exactly which way you want to go, there's also the Electric Auto Association, which is an enthusiast organization, basically, with chapters around the country. They've been around since the 1960s. There's 60 or 70 chapters. So if you also want to hook up with more local enthusiasts that know the technology and are happy to have these discussions all day long about the different opportunities in your area, then that's also an opportunity. If by EV systems you think more on the infrastructure side, that's kind of an electrician. Site design is really important and hard to come by all the charging networks, and real estate really oddly is becoming a huge need in this, those that know how to negotiate that space. So as much as we think about sort of one particular technology, there's all these adjacent fields that, depending on your interest, could be really useful.
There should be numerous jobs in this field in the future. Any type of technical training, whether it be automotive, electronics, mechanical, any type of engineering. These vehicles are loaded with electronics. So electronics training would be extremely useful. That's the most sophisticated part of these vehicles, is the electronics, the battery maintenance systems. They're very sophisticated and technical. So I think there'll be a lot of jobs in the future in this field.
Yeah. And especially on things beyond the forklifts and stuff, most are looking for ASE master techs as it is. So in addition to the specialized EV side of the training. So I would also start there as a really good foundation.
Yeah, and I can speak to this as well. Here at Fourth, our role is primarily to support the increased adoption of electric and smart vehicles throughout the vehicle transportation ecosystem. So per Wade's comments, and I think in support of what Chelsea and Dale were saying, there's going to be a lot of opportunities here. And I would invite you to keep an eye on what's going on in the utility industry. They're going to have the most at stake, at least over the next few years, in growing the adoption of electric vehicles. And that doesn't even speak to the engineering needs of automotive firms and the automotive support industry, all of the suppliers to the automotive industry that are going to need to make the transition from internal combustion to electric. And so the opportunity set is real and growing fast. Maybe we should move on to our next question. Is there a sound, and this might be more a Dale question. So is there a sound emitting option that can be turned on so pedestrians Dale and Wade, sorry. Is there an option that can be turned on so the pedestrians are more aware of the neighborhood electric vehicle as well as the forklift? So we're talking about minimizing or actually, no, we're talking the opposite. We're talking about making pedestrians aware that these vehicles are operating.
Yeah, as far as forklifts go, there is an option to throw like a bell on there as you're driving and moving, stuff like that. It'll kind of ding. That way people can hear you. We chose not to have that on our forklifts, but we do have that. Always in reverse. Anytime you go in reverse, there is an audible beeper that does sound. On our forklift, we also have what's called a blue light. So whenever you put in reverse, there's a blue light that goes on the ground. That way, anyone standing behind you too can also see that blue light on the ground, knowing that they could be in an area that the forklift is going to back. The forklift does come with a horn, so anytime you're going in and out of doors, you sound your horn. Same thing could be done as you're coming up to pedestrians on a forklift or on a sidewalk or out in a parking lot or something like that. There are ways to make it audible. but the forklifts are quiet.
Dale, what about neighborhood electric vehicles?
Ours are quiet too, the e-rides, but they do have a backup beacon so that when you're in reverse, there's a beacon. There's also a horn equipped, but other than that, they're pretty quiet. I've heard a lot of talk in the industry though about putting some type of speaker on these vehicles in order to admit, sound so that pedestrians do know that you're coming. So I'm sure that's going to come in the future.
Yeah, the precedent is already there for anything on the road. I saw the question came about parking lots as well. The Motor Vehicle Safety Act of 2012, which is fairly darn nerdy, requires that anything with an electric motor, even gasoline-only hybrids, also have a noisemaker on it for forward and back below about 35 miles an hour. So it's meant for in-town, sort of more urban stuff where you'd encounter pedestrians, not so much on the highway. But preemptively, most manufacturers already started to put those on. There's a little bit of debate now about should they have some flexibility in what sound they use, or do they have to all be exactly the same? But most EVs that are larger already have that sound somehow. But there's also aftermarket options for those that want to put them on. And coincidentally, my school district has a vehicle yard across the street, and I have been strategically muting their backup horns through all of this.
Thank you, Chelsea. This next question might be for Dale. Can you remind this person what departments use the e-rides?
That's more BSU. I think we have one in our company, one or two, and they're down in our Hell's Canyon area, the power plants, things like that.
Mm-hmm.
And I believe we are going to look at getting more for down and around in those areas. But as far as the smaller electric vehicles, that's about what we have right now.
Yeah, Wade, what about you?
Our e-rides are used here by our maintenance staff and by our custodians. And they do 2 shifts a day. So the maintenance staff starts with them in the morning. They come in and work an 8-hour shift. And then when they leave, they plug them back in. And then the custodians come in the afternoon and they use them in the evening. And then when they're done with them, they plug them back in.
So this next question, I think, is for all 3 of our panelists. What are some of the maintenance expenses related to electric trucks?
For IDAHO Power, it's ours are actually our forklifts are lead acid battery, so we do have some filling of those. So you do have some water cost in there. You do have some terminals to keep clean from time to time. Every day you do an inspection when you go out to the forklift. Part of that is looking at the batteries. So that is something that we look at daily before use. But for the most part, they're pretty dang maintenance free. That's other than greasing up some zerks here and there, they're pretty good.
The maintenance on our e-rides is very limited. Of course, you don't have any oil to change. There's no coolant in to take care of. They are automotive based, so you still have tires, but they're really good on tires. They never wear out. We only replace them because of time. So the maintenance on them is so limited. We've had a few small problems. They have a heater contactor that we had some issues with that we had to replace. It was basically a contactor to turn the heater on and off. But E-Ride has changed that part, and they've made a more robust component now that doesn't fail as often. That's one of the things we've really noticed. When they have a problem, they identify it and they come up with a solution, and generally they redesign the part. And like I said, their service is incredible, but the maintenance on these e-rides is very minimal. But ours all have the lithium-ion batteries as well, so that's a big part of it. We have a lot of golf carts here that have the lead acid batteries, and we have to service those batteries regularly. And one of the things we found here with the lead acid batteries is often our users take the vehicles and then we don't get them back, and the batteries get low on electrolyte, and they charge them and overheat the batteries and damage the batteries. So that's one of the reasons we really like the lithium-ion batteries. And it's maintenance takes time, And with the lithium ion batteries, there's almost no maintenance on the batteries. So maintenance is really reduced with the electric vehicle as opposed to a conventional powered vehicle.
Chelsea?
Yeah, I agree. I mean, it basically comes down to consumable items: tires, windshield wipers, windshield wiper fluid, and then could be batteries depending on the technology and how long you have it. Most lithium batteries are warranted to 8 to 10 years. We've got 10-ish years track record, real world track record on the oldest vehicles in this EV generation, and we have yet to see. And that's passenger cars, but still, those are the oldest ones, and they're the same types of batteries that are used in larger vehicles. And we've not really had any significant issues across the space. So overall, everyone's encouraged that they're lasting longer than we would expect them to. Also, that because battery prices have fallen 90% since 2010, we kind of accept that at some point, if you keep something long enough, you may want to change those batteries, but it will be far cheaper to do so by the time you would ever want to. So overall, it's more the tires type of issue.
The next question was essentially the same about the comparison between the cost of ICE vehicles and servicing them, as well as the comparisons to electric vehicles. And I think you guys have done a pretty good job covering that, I think. Are there any other areas that hold potential savings between ICE vehicles and electric?
Fuel costs are extremely reduced for us. You saw the graph that we had.
Yeah.
The difference in fuel is incredible. In
Yeah.
Idaho, our electricity is very affordable, so we're really fortunate in that way. So if you look at the cost of charging an electric vehicle as opposed to putting fuel in a conventional powered vehicle, there's substantial savings in the fuel costs.
Yeah, on average, electricity as fuel is about a fourth the cost of gasoline, with a little bit of regional variation. I haven't seen as many hard studies on the financial aspects of maintenance in these classes of vehicles, but I'll say that to the extent I've seen research on the topic of EVs versus gas in general, mostly it's pegged around 60% cheaper for EVs. So I won't say a hard number on delivery vans versus cars, but that's the ballpark.
So the next question really moves us into the realm of electric vehicle infrastructure. Obviously, we've all grown up with infrastructure around supporting internal combustion engines around fossil fuels, but now we're looking with this new, with the growth and the advent of electric vehicles, of the infrastructure needed to support those. So, so what is the cost? What are you seeing for the cost of infrastructure to support your electrification needs and the direction that things are headed?
Is anybody an expert? Dale?
Yeah. For us, I really don't have those cost breakdown in front of me. I know I can get them. I know I can provide them afterwards, but I don't have them right in front of me. I know, at least personally in my area now, I used to run a propane forklift. Now, since we're going off electricity, battery powered one, I don't have to pay for propane, and we're the power company, so we don't pay ourselves power bill. So it's one of those things that works out pretty well.
It really depends on what charger you have. So these new electric vehicles, most all of them come with a level 1 charger, which means it can be plugged into a 110 outlet. And most facilities already have that infrastructure in place. So there really wouldn't be a cost associated with that. But most people that have electric vehicles opt for a level 2 charger. A level 2 charger is a 220 volt charger. And we've priced those chargers, and there's different types of chargers. There's standalone chargers and there's hooked up chargers, which means you can access the data. The standalone chargers are anywhere from $400 to $600. And then we actually asked some local contractors here in Boise what it would cost to get one of those wired. And total cost by the time we bought the charger and had it wired was anywhere from $800 to $1,200. And then the third level of charging is the DC fast chargers. And I'm not sure what the cost of those is, but it's quite expensive, and it's not a A consumer would not get a DC fast charger. That would be something like VRT here in town in Boise. They're getting electric trucks and they're putting in DC fast chargers. So anyway, we have another gentleman here at Boise State that does the charging for us, the infrastructure, and we could certainly answer the questions better consulting with him on that.
You actually were completely, I mean, yes, you're right. And there's a couple other variations in there, but just over half of EV drivers, even the Tesla folks, still actually use the 120 volt, household outlet chargers. They don't even bother to go faster because they don't drive more than 30 miles a day. So an overnight charge does it for them. As we get, and certainly for forklifts and neighborhood electrics and things like that, often many of those are adequate on that level of charging, which is about 4 miles per hour of charging, give or take, depending on the vehicle. But that's roughly the ballpark you'd be looking at without buying anything. Level 2 chargers, 240 volt outlets, are $400 to $600, up to a few $1,000s for one that's very weatherproof and meant for very public use, and that you can have accounts and monetize and use for public use and things like that. So they can get very fancy, but the basic ability to charge faster is not that expensive. You're right that to wire a 240 volt circuit, 40 amps or so, is usually $800, depending on where you are in the country. DC fast charging is rarely needed at a non-industrial, non-roadside truck stoppy site. So most companies and facilities don't need it except for really industrial use or really trying to do quick turnarounds, taxis, things like that. The cost of those is, there's now a range of DC charging speeds. So the hardware is $15,000 to $20,000 per box, up to sort of $75,000 for the fastest boxes right now, and a roughly equal cost to install it. It's not for the faint of heart, but it makes sense in certain places to enable longer road trips and to enable certain duty cycles.
Great. Thank you, Chelsea. So the next question might be more appropriate for Dale and or our other panelists, Boise State. Have you received pushback, or do you have any techniques that you've used to kind of respond to institutional resistance? Because you're both change advocates here. You're both trying to change the way transportation has been done within your organization and moving from fossil to electric. So do you have any tips, techniques that you'd like to share with us about how to manage that change and how to, move things along within your organization?
Well, anytime you get any new piece of equipment, a lot of our operators, they do get tied to their old machines, and they love those things. The cup holder fit their mug just right, and all that good stuff. But it's one of those things. You actually get them out there on it. You let them try it. They're able to see the efficiency in it, and usually the cup holder will still hold their cup, so they're still happy about that. But a lot of times it's learning a few new controls, maybe from being a lever style to more of a fingertip style, for maneuvering your forks up and down, to adjust the tilt, all that good stuff. But where I'm over the area, it's one of those things I a lot of times tell the guys, hey, we're going to give it a shot, and if it doesn't work, it doesn't work. We can always go back, but why not give it a shot and let's see if we can make it work. Always giving them that option, letting them know that, hey, if this just isn't for us, and we can always go back, that does usually put their minds at ease. And all the times we've done it, have we ever gone back? No. We've always gone forward with a new piece of equipment, and it's worked out well for us. They do get a little battery shy, distance shy, stuff like that every once in a while, at first. But once you run through it, they find out that it sucks a lot more to carry a propane tank from the middle of the yard all the way back and swap it back and forth versus driving up to the plug-in. They would much rather do that and have that money.
So Wade, how about yourself?
People are certainly resistant to change for some reason. One of the things we like to do is we like to look at where the vehicle is going to be used, how it's going to be used, and we try to make sure we get a vehicle that's going to fulfill the operator's needs. Because if it won't fulfill the operator's needs, it's not going to work for them. So we like to get input from the operator. We like to listen to what they need, how it's going to be used. And then from all the input that we can gather from the operator, then we like to give them several options. We like to bring in several units that can fulfill their needs and let them look at the units, let them try the units out, let them see which one they like, see which one's going to work the best. And then, we involve them in the decision-making process. So we're not saying, here's the vehicle that's going to work for you guys. We like to collaborate with them and work with them and let them help us find the correct vehicle for them, the one that's going to fulfill their needs. And then with electrics, we have found the infrastructure has to be in place before the vehicle arrives. If you give them an electric vehicle and they don't have anywhere to park it, charge it, it's not going to work. And we kind of learned that the hard way. So we want to make darn sure the infrastructure is in place before we deliver the vehicle to them now through experience.
Chelsea, your thoughts?
They're right. They're absolutely right. And I would reinforce that experience helps a lot. That you can logic your way through a lot of it, and absolutely that has to happen. But the experience of electric vehicles is generally better. That quietness is nice. They're smoother. They're kind of torquey, and so depending on the kind of car, it's more or vehicle, forklift, more fun. There's a little bit of that. Just as much as humans are afraid of change, humans also resonate to that experience, even if it's a fleet driver that technically shouldn't care, versus your own private car. There's a little bit of that too. So letting them see, touch, drive, see it's not so unfamiliar, see that it's better in certain ways, and often ways that are unexpected, helps a lot. And you add that to the layer of, look, it actually meets the needs we're trying to solve here, and you're helping to guide us on this. Wade's right. Dale's right.
So they're incredibly torquey.
I know.
The power they have is incredible.
That's always the number one comment that we get too. Yeah. It's instant. It's right there. It's no lag, nothing like that. A lot of times with propane forklifts, things like that, you turn your wheels really, really sharp. You try to go, and sometimes that motor will cut out. With the electric forklift, you can crank it as hard as you want. Even maneuver the forks if you need it, and that thing is not shutting off on you. So it's definitely nice there.
So it seems like you guys are all change agents, and what you're finding is that you identify additional change agents within your organization to really keep this transition going. Because if I'm not mistaken, what I'm hearing is kind of this sense that electric is the future. And so the next question we had submitted was, what's the average battery life for a battery, both the lead acid and the lithium ion? And how long does a typical charge last? Especially, I think in the off-road, non-light duty vehicle space.
I know for like us, our forklift, I'd give it a good solid 8 hours of runtime. Is what you'll get battery life out of it. Nice thing is overnight charge, you're ready to go the next day. At least in my area and what I've talked to in the other areas, that's what they're finding too. Since we don't actually operate our forklifts, all 8 hours of the day during the workday, usually that charge will last us, like I said, usually 3 days.
I'll talk a little bit about battery life. With the lead acid batteries, battery life can be anywhere from 2 to 5 years, but maintenance is critical. If you let them get low on fluid and you overheat the batteries, that substantially reduces battery life. So with the lead acid battery, maintenance is really, really critical. The battery life on the lithium ion battery, they say it's up to 4 times longer or up to 20 years possibly, depending upon the number of cycles. The nice thing about that battery is there really isn't any maintenance on that battery. And one thing about the lithium ion battery is it has a very sophisticated charging system. They have a control module that controls charging and discharging. And if that's all programmed correctly, you should get at least 2,000 cycles out of that battery, according to E-Ride. E-Ride also stated that they've seen many vehicles with well over 2,000 cycles on them. So, maintenance is a huge thing on battery life. We don't have any problems with our batteries going dead here on campus. We don't drive very long distances though either. So, they drive across campus, they work, and then they drive to another spot. That 100 amp hour battery, which we have in the E-Ride, they say it's 30 minutes of continuous operation and 55 on the 200 amp hour. So, that's kind of what I had for that.
Another thing that I know that we're seeing even throughout all of our departments too is one of the big things on battery powered, even though we're still with the lead acid batteries, we're not noticing any kind of shortening of battery life due to the battery memory of, let's say you're not completely dead, you charge it at 50, whenever it's at 50%, you charge it back up. We're not seeing any of that lowering of the battery life due to that. Mm-hmm. I know that our charger itself, it does equalize the different ports in there. It's definitely a nice charger. Our forklift is 580 volts, if I remember right. So it's a big battery. So we we definitely utilize it, and no matter what, always on Fridays, we always plug it in no matter where it's at, because on Sunday is when the charger will automatically run its equalization for that battery. And again, we haven't seen any memory forming on the batteries themselves for battery life.
So Chelsea, what about, now we're looking at these delivery vehicles. You talked about the Rivians and the Lordstown. What's the expectation? Because a lot of those vehicles aren't going to necessarily be driving, hundreds of miles, but instead will be used on a daily basis to support deliveries. And what's the expectation? What have you heard about expectations in that realm?
It's similar. At the end of the day, range is as long as you want to make it. If you stuff enough batteries into a vehicle, it'll go as long as you want. And so it becomes a trade-off of the range you need versus cost, because at some point it's diminishing return to add more batteries that you're not really going to use on a regular basis. Mm-hmm. And so that's the balance that each of these are going to try to strike for their particular vehicle size and class and what it's meant to do, long haul versus urban, last mile, all of those things. Mm-hmm. It's true that there's generally not that much maintenance. There's even maintenance-free lead acid batteries now, and has been. So we used on EV1. None of them really have memory issues, and certainly the lithium batteries are valuable enough, expensive enough that they have highly sophisticated software. So that helps manage some of that sort of thing. Even though none of them have memories, lead acid can get sulfated. They're each a little thermally sensitive in their own individual ways. And so the software helps a lot with that kind of thing as well. And sometimes you see differences in winter versus summer, the same way you do on an internal combustion car that just isn't as efficient in the winter. So EVs get pegged for a lot of things that are kind of endemic to vehicles nationwide. But as I said, generally we're seeing 10 years is not even a concern anymore. At this point, we're sort of looking for what's the ultimate end beyond that. And some never will. Some will get to a point where the range falls off enough over time, just like your laptop battery doesn't last as long 5 years in as it does when it's new, that people will want to change either the battery or the vehicle. Others will still find that on a day-to-day basis, it meets their needs for 20, 25 years, and it just never becomes a thing that has to be replaced as long as it still works.
Thank you, Chelsea. Our next question is about Idaho Power, so I'm hoping Dale might be able to take it up. It's, what do you think is next for electrification at Idaho Power in terms of your off-road vehicles, and then any thoughts you might have beyond that?
Yeah, right now we started off with our electric cars and stuff like that. The Leaf, the Volt. What else have we had? I think we may have even had a Prius in here too, but we've had a lot of those. Then we started on with working with Ford and I cannot remember the local company's name, but adding a battery pack into some of our F-150s, and to try to almost create our own type of Prius out of the normal Ford F-150. And it seemed to be doing okay. There's definitely some learning curves. We lost a lot of payload. Those batteries aren't light, so we did lose a lot of payload. So it's really encouraging whenever we heard Ford, I believe in 2021 or 2022, is looking at coming out with the new F-150 that will be an electric vehicle. We are interested in seeing what happens there. For forklifts, again, we started that. A lot of people have always used electric forklifts inside warehouses. Usually your smaller ones, things like that. It's these larger ones, like your 5,000, 7,000, 9,000, 12,000 pound forklifts. Those are the newer ones now coming into being electric forklifts. So far, we've had great success with them. It's something, as I can see going forward, we'll continue to use. Again, some of the stuff that we're looking out in the field, because some of the places that we do go to, we're going there to actually make power available. So there isn't any kind of power, any kind of charging ports, stuff like that out there. So it's looking at like telehandlers, skid steers, things like that. It'll be interesting to see what the different manufacturers come up with going into the future, especially for some kind of charging. I don't know if they can throw on solar or something like that to help with that, but that I believe will be the next thing. I'm sure whenever it comes about, IDAHO Power, we will look at it and see if we can utilize it.
Thank you.
You're
So,
welcome.
Chelsea, we haven't talked much about electric buses. What do you see happening in that space?
Buses are becoming kind of hot, actually. I didn't cover them because we were more on the vans goods movement piece, but the biggest company of electric vehicles worldwide is called BYD, and it's one of the two most common bus manufacturers. It's one of the vehicles they distribute also globally. Many of their cars and stuff remain only in China. So they're one. And then a South Carolina-based company called Proterra is sort of the American darling of bus companies. More recently, New Flyer and some of the incumbent manufacturers are getting into it as well. And they're getting a bit more of a push, both sort of transit buses and school buses, in part just for recent interest in cutting pollution, but also in the wake of the Volkswagen Dieselgate settlement. Part of that settlement was roughly handing $6 billion over to the states to decide, based on how many diesel vehicles were in the state to begin with, you get a prorated amount of this money. You get to decide as a state how it gets spent. One of the things it can go towards are electric school buses and some amount of infrastructure to support them. And so many of the states have actually voted to use their funding for this purpose. And so we are seeing much more interest and some actual funding to back it up for buses. Not enough yet, and certainly all things transit in the wake of COVID are a different conversation. That's another struggle, but the appetite for electrification of that segment is high.
Wade, how about Boise State? Any movement toward any of your smaller buses toward electric?
We haven't. We have small shuttle buses, and we haven't moved towards electricity on them at all at this point. But we've currently identified 84 vehicles in our fleet that an electric or a hybrid will work very well. So we're going to move. We're going to move that way as quickly as possible. Right now, our security team, they're going to move to hybrids. We haven't got them pushed to electrics yet, but this year Ford came out with a hybrid Interceptor, and they're on board for going with the new hybrid Interceptor. So our security team, our next security vehicle, we're going to get one of those and see how it works. And we're very confident it's going to be super successful. And we're hoping that'll be a bridge to an electric down the road. We can't quite get them to go that far yet, but electrics work really well here on the campus. Range isn't much of a concern here because we don't travel long distances. We travel short distances. So we really don't have a range issue here, but we currently have 84 vehicles marked that we're going to be moving to either a hybrid or an electric footprint in the near future.
Okay, so one last question, and real quick here, we can go around to everybody, but what's this may not apply so much to the lead acid batteries that Dale uses because those have a pretty well established recycling system. But in terms of lithium ion, as Chelsea mentioned, we're still, the initial lithium ion batteries are not yet at the end of life. But what are we seeing happen as we look into the future where we have, a significant amount of lithium ion batteries reaching the end of their life? Is it recycling? What are the issues?
Yeah, and I mean, I do handle a lot of our hazardous waste disposal, stuff like that, and recycling of different kinds of batteries.
Mhm.
We do have some other lithium ion batteries, definitely
Okay.
computers, things like that, in some of our power plants. We utilize that technology, and those things can be recycled. There are recyclers out there.
Oh,
The
great.
plastics can be recycled. The gel themselves can be recycled. The aluminum that's inside there. There's so much of it that is truly recycled. You don't get a lot of waste off of it. It's basically it's turned it's broke apart. It's all the different properties are segregated. Then it's basically remanufactured into another battery.
Thank you.
Yeah, we haven't had appetite for throwing batteries in the trash since we started putting one on every vehicle on the road. And so the lithium recycling chain is newer. There are fewer folks doing it yet, but it is definitely there. And we have been doing it some on vehicles because electric cars are not immune to crashing. There are other ways for them to meet an unnatural end of life. And so some have been recycled. But in between those two things are also a second life opportunity. So quite a few batteries that are too degraded to work really well in electric vehicles for traction purposes still have lots of energy left. And so there's quite a bit of exploring and pilot deploying of grid storage as battery backup or portable batteries, resilience purposes, those sorts of things as well. So, when these Leafs have batteries that are old enough to not provide great range anymore, they still can be used for that purpose. And so that will continue forward. And there will be many batteries we see a couple of lives out of, maybe more, before they are finally recycled, depending on the economics of how that shakes out.
So Wade, we got about 30 seconds left. Any closing thoughts on that issue?
We see the manufacturer. We think the manufacturer is going to start taking back the batteries and recycle them, just as they have with lead acid batteries. That's kind of what we've been talking about, and there are more and more recyclers coming up. But these batteries are absolutely going to be recycled, just like the lead acid batteries have been.
Well, thank you. Thank you all. Thank you, Dale. Thank you, Wade. Chelsea, it's been a wonderful presentation. Thank you for your insights. Thank you for your experience. And thank you for wonderful presentations today. I will turn it back over to Crystal.
Hi, everyone. Thank you so much. I first want to thank all the speakers and our wonderful moderator. This was a fantastic webinar, and I'm very excited to have been part of it. You could see the contact information. Apologies, it seems to have been a bit distorted. And a big, big thank you to Idaho Power and Treasure Valley Clean Cities Coalition for sponsoring this webinar and making sure it happens. I look forward to seeing some of you in our webinars to come next year, and I hope that you have a fantastic end of year. Again, thank you. Thank you.
You're very welcome. Thank you.